Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be solving or finding the side length of a figure using the concept of similarity. Okay, let's start with this first figure. Find the length of DE. As you can see, we cannot see any conditions written in this problem. So to answer this, we have to use the concept of similarity. Okay, this bigger triangle has smaller triangle inside. So let's say this is our bigger triangle. So this is A, this is point B, and this is point C. And this is the smaller triangle. So this is point A, D, and E. So A, D, E. Side AB is 8 plus 4, so this is 12. Side AC is 6 plus 10, so this is 16. And BC is 18 centimeters. Okay, what about here? AD is 8, AE is 6. So this is 8, this is 6 centimeters. And we are looking for this side DE. Okay, to find the measure of side DE, let's find out if these two triangles are similar figures. Okay, will it be SSS similarity, SAS similarity, or AA similarity? So in here, okay, obviously we cannot use SSS similarity. It's because one side is missing or we don't know the length of one side. Okay, what about AA similarity? We cannot also use AA similarity because we only have one pair of corresponding angles that are equal in measures. And that is this angle. So this angle A, these are common angles to these two triangles. Okay, so in here, we are going to use SAS similarity. Okay, now, let's find out if the ratio of the length of the two corresponding sides are equal or constant. So in here, we're going to name this triangle as triangle ABC. So triangle ABC. Okay, what about here? In naming this triangle, we have to consider the corresponding points, corresponding sides, and angles. So this is triangle. Since this is triangle ABC, so we now have triangle A. Okay, AB is 12 centimeters. AC 16 centimeters. So this is shorter, this is longer. So in here, 6 is shorter, 8 is longer. So it means AE corresponds to AB. So this is AED. So we have triangle ABC and triangle AED. Okay, it's given that AB is 12 centimeters. This side AB corresponds to side AE, which is 6 centimeters. Okay, let's find out the ratio of these corresponding sides. So we have here 12 is to 6. And if we will simplify, this is 2 is to 1. So the ratio is 2 is to 1. Okay, how about side AC? Side AC corresponds to side AD. So AC is 16 centimeters. AD is 8 centimeters. And if we're going to simplify, this is also 2 is to 1. So the ratio of the length of the two corresponding sides are equal or constant. So it means these two triangles are similar figures. So we have here two sides and angles. So SAS similarity. So from this, we can now find the length of this side DE. So we are going to make use of the ratio 2 is to 1. So 2 is to 1. This is now equal to, okay, this side DE corresponds to this side, BC. So BC is 18. Okay, is 2. This is, let's say, X. So this is 2X is to 18. So it means X is equal to 9. So the length of DE or of this side DE is 9 centimeters. Okay, moving on to our second figure. This time, in this figure, we will find the length of AD or of these lengths. Okay, there is no given or written conditions also. So we are going to use the concept of similarity to answer this question. Okay, as you can see, we have this triangle and inside we have two smaller triangles. Okay, let's draw this bigger triangle. So this is point A, this is B, this is C. So A, this is B, and this is C. And inside, we have two smaller triangles. Okay, so we have two smaller triangles. So this is point A, B, D. So A, B, D. And we also have this triangle. So this is point A, this is D, and this is C. Okay, side AB is 4 centimeters. BC would be 2 plus 6, so this is 8 centimeters. AC is 7 centimeters. What about here? AB, so this is 4. BD, this is 2 centimeters. And we're looking for this side. So AD, this side. What about DC? So this is 6 centimeters. AC is 7 centimeters. Okay, in this kind of figure, a figure and then there are smaller figures inside the bigger figure, okay, it means that one of this triangle is similar to this triangle. So we have to find out which among this triangle is similar to this triangle. So first, we're going to check this triangle and this triangle. Let's see if these are similar figures. So if we are going to check these two triangles, they have common angle, and that is this angle. So angle B is common to this angle. And again, we cannot use SSS similarity because one side is not given. We cannot also use A similarity because we only have one pair of corresponding angles that are equal. So we are going to use AS similarity. So let's find out the ratio of the length of the two corresponding sides. So first, let's name this triangle ABC. So triangle ABC. Okay, so B, common angle. B, so it means this is triangle, so B is here. Okay, if we're going to check, this side is shorter than this side. So here, this side is shorter than this side. So it means D corresponds to A. So we have D, B, A. So triangle ABC, we have here triangle D, B, A. Okay, now, AB, DB, let's find out the ratio of these corresponding sides. AB is 4 and DB here, DB is 2. So 4 is to 2 and this is equal to 2 is to 1. So the ratio is 2 is to 1. Okay, now, how about BC? That corresponds to, okay, BC that corresponds to BA. So BC is 8 and BA, we have here BA. So BA is 4. So this is 8 is to 4. And if we will simplify, this is also 2 is to 1. So we already proved that this two triangles are similar figures because two corresponding, or the ratio of the length of the two corresponding sides are equal, and we have here one pair of corresponding angles. That's SAS, similarity. So these two triangles are similar figures. Okay, how about this triangle and this triangle? So we have here triangle ABC, and if we're going to name this triangle, we have to consider the corresponding points, sides, and angles. This triangle and this triangle have common angle, and that is this angle. So common angle. So if this is triangle ABC, then this is now triangle. Okay, C is here. So here, this is longer. What about here? This part is longer. So B corresponds to A. So this is A. So this is now D. So triangle ABC and triangle DAC. Okay, now BC is 8 centimeters. BC corresponds to AC. AC, which is 7. So this is 8 is to 7. Okay, what about this time? What about, okay, AC, DC. Okay, so we have AC. AC is 7 and DC is 6. So as you can see, these two corresponding sides are not equal or constant in, or the ratios are not equal or constant. So it means these two triangles are not similar figures. So in here, we're going to use then this ratio 2 is to 1 to find out what would be the length of AD. So the ratio is 2 is to 1. Okay, we are looking for this side, AD. Okay, AD corresponds to AC in this figure. So AC is 7. So it's to X. So this is now 2X is to 7. So it means X is 7 is to 2. So the measure of this length, or of this side of this triangle, is 7 is to 2 centimeters. So that would be the length of AD. Okay, and for the last figure, let's find out the length of BE in this figure. So there is no given conditions, or there's no written conditions. So we are going to make use of the concept of similarity. So this bigger triangle has a smaller triangle inside. So let's say this is our bigger triangle. This is A, this is B, this is C. And we have this smaller triangle. So this is D, this is E, this is C. So according to this figure, the measure of this angle is same measure to this angle. So A, and this is in this figure, this is angle E. So they are equal in measures. And also, angle C is common to these two triangles. So angle C is common to these two triangles. So from that, we can now say that these two triangles are similar figures because they have two pairs of corresponding angles that are equal in measures. So triangle ABC is similar to this triangle. Okay, to name this triangle, okay, A, so this is triangle E. Okay, A, okay, and this is C. Okay, C, so this is C. So this is now D. So triangle AEDC. So triangle ABC is similar to triangle EDC. Okay, let's indicate the measure of this side. AC is 2 plus 6, so this is 8. BC, this is, BE is actually the one we're looking for, so let's say this is X. So it means BC is x plus 4. So x plus 4 centimeters. What about here? BC is 6 and this is 4 centimeters. Okay, we actually don't know this side. Okay, first we have to find the ratio of the length of the corresponding sides. So AC, EC. So it's given that side AC is 8 centimeters. Okay, what about the corresponding side, which is EC? It's 4 centimeters. So we have 8 is to 4. And if we will simplify, then the ratio now is 2 is to 1. Okay, we are going to use the ratio 2 is to 1 to find out the measure of this side BE. So it means 2 is to 1. This is now equal to, okay, this side BC is, corresponds to this side DC, which is 6 centimeters. So this is x plus 4, okay, is to, side DC is 6 centimeters. So it means this is x plus 4 is equal to 12. So x now is equal to 12 minus 4, and that's equal to 8. So it means BE is 8 centimeters.